Thank you, Eric. Thank you, everyone, coming here. So my name is Minwoo Lee, an assistant professor at UNC Charlotte. Today, I will talk about it's not talking about, I would like to discuss about the future of humans and AI and how we're going to manage it, or how actually we need to prepare for it. All right. So we are living in the era of AI. So unlike like 20 or 30 years, even in a short past, I think AI was not when the AI was not as close as nowadays. But we didn't too much, even we have some novels, SF novels, talking about some possible threat of the AI, right? And so we have a lot of what if questions nowadays, even more, because there are a lot of these articles and news and media actually talking about this. Yeah, AI have accomplished this, and we have a lot of talk about the advances of an AI a lot. So people kind of bring up this what if question, such as, what if we lose our job? Or what if AI replaces us? Or even more seriously, what if AI eliminates us, right? And then this will be very interesting discussion. So I will share some of the background to initiate the discussion. I would like to all involved in this discussion because I think it's interesting, right? All right. So yeah, talking about myself. So I am a machine learning researcher, and most of my work focuses on reinforcement learning, which is a kind of machine learning that trains the AI agent by giving reward, like we training a dog, right? So whenever AI accomplishes a goal, we're giving reward, then AI kind of learns some of its action kind of reinforced to be repeated. Then eventually it develops a good way to solve a problem. And I'm co-directing vision and image analysis lab in UNC Charlotte, and I'm leading the machine learning group there as well. And I am a member of the UNC Robotics Consortium, and I'm affiliated at School of Data Sciences as well. So this is me, and this is some of a few of my research in the past few years. And my work, as you can see, a lot of keyword with the reinforcement learning, right? Oops, it's a little slow. Reinforcement learning. So many of this work is kind of focuses on how I can make this reinforcement learning agent learn fast. Oops. So if you above here, this paper talks about how we can make AI practice before they actually solve the reinforcement learning task. And that actually works and well to improve the learning speed of AI. And then this paper is talking about the snapshot memory. So what we actually learn, whenever you actually do something, we do not memorize every single moment. We memorize most important things from the past. And then some of those memory I call that a snapshot memory, actually helps you to learn or solve other problems. So this paper talks about how we can actually store the snapshots from this AI's learning process, right? And this experience replay is some of the way that we store these memories and then efficiently take out and train memory. So it is kind of related to the research, how we can actually construct this memory so we can make our AI's learning more efficient. And this paper is talked about how reinforcement learning can be used for the optimizing network routing. So we have other papers and that apply reinforcement learning in robotics. And also this one is like kind of unique because network performance, Wi-Fi performance can be much faster by incorporating or optimizing depending on the traffic situations, and then we can distribute the traffics evenly or more efficiently, and we can have a better or the throughput or shortened delay for the networking, right? And it has been applied, the machine learning has been applied some of the natural language processing as well. And this work is kind of interesting that is using machine learning to identify a person, but just simply using the human working. So it is kind of well known that everyone has unique the working pattern, which is called gait. So, and this can be used as like a fingerprint, right? So if you know that the gait is human identifier, then why don't you use some sensors to recognize the human gait and to identify a person? And this research, we use a sensor, which is something that we have around, which is Wi-Fi router. So simply using Wi-Fi router and then put your laptop to be in between and then let people walk around between the router and laptop, and we collect the Wi-Fi signals and then to identify who is working in between there. Well, this is the type of research that I'm working on, and these are the students and some past students and a mix of the current students and to do this kind of research in our lab and in our group. So that's about me. Now let's think about how AI has been evolved and to better understand or to better initiate our discussion. Okay. So this is a slide from the CGG that will summarize this the histories of AI development. So in 1950, Alan Turing kind of suggested or the proposed Turing Test. What Turing Test means is if a human cannot distinguish if it is machine or the human, then we consider that as this model has passed the Turing Test. So for example, if it is natural language processing or chatbot, and then while you are chatting with the chatbot, if you think it's a human, then we think that it has passed the Turing Test. So the term AI is born in 1955, and then first industrial robot has been developed and deployed in GM in 1961. And Eliza was the first pioneering chatbot developed at MIT in 64. And then Shaky is an electric person that is from the Stanford. And it is designed to general purpose mobile robot in the 66. It was way early, even I was born. And then afterward, we have actually 2 winters because of this kind of some false start or like some fun for the AI is kind of frozen. And then people thought it might not be effective. So when I was a kid, what I heard from the other people is saying about the AIs, what you can do AI is just simply making the washing machine. I think around the 80s or 90s, there's the fuzzy washing machines. They're using some fuzzy rules like randomizing the wash flows to clean your laundry with the washing machine. That was a kind of hit those days, except that there's no hit product with an AI. So that causes an AI winter, and there are not much of advances during that period. but in some innovative work actually booms the certain field. And Deep Blue is one of the kind. In 1997, Deep Blue from IBM actually beat the chess human champion and in 1997. The Kismet is like a robot, as you can see in the figure. It's this robot that actually shows these emotional expressions. And it's a funky face down here, right? And afterward, the first commercial like a pet robot, Aibo, was come out in 1999. And then Roomba maybe is kind of popular with this the cleaning machine. Was first developed in 2002. And then you must be using an iPhone. Siri was first designed and then and out in 2011. And 2011, at the same time, IBM Watson actually beat the two other the Jeopardy champions, and it is kind of harshly beaten. I'm not sure if you watched that video. This was in 2011. Very interesting. It immediately answers the question because it requires to understand the human tongue, and then afterward it find the answer and then pick up the answer that has the highest probability, and the computation for the entire process is quite fast to beat and the quizzes show. Right? And then Eugene is another chatbot, and then it's the first the chatbot that passed the Turing Test. And Alexa was out in 2014, and 2016, Tay was kind of go wrong in 2016. I would like to highlight this Tay here. It is interesting that Microsoft opens these the chatbot and then let it learn from the people's tongue from online. So from this Facebook or social medias and everything, that they collect this conversation, any conversation that comes into the Tay, and they learn the tongue from it. But it happens in that task only one day. It got wrong and then became the offensive racist. It's very offensive in the racism and the politics and everything. It mimics the teenage tongues, and then it come up with one of the examples that I saw from the article was, so when one customer asked a question about if the Holocaust happened or not, and then Tay replied it was made up. Right? So you can see the machine learning is one of this kind of core of these AI advances nowadays. It learns from data. So when the data is contaminated or tainted, if you do not have a good quality data, your model can be easily messed up. So Tay is one of the good examples that shows that how AI can be easily go wrong. And then afterward, this one has only up to 2017. Alphago is one of the recent big advances in AI that they kind of activate more of this or extended AI, deep learning, and reinforcement learning research. Using deep reinforcement learning algorithm on AlphaGo, learn how to play the Go game. I'm not sure how many of you actually know the Go, but maybe you may heard about the AlphaGo already. from the article. So Go has a, you're playing the kind of chess-like board game with this 19 by 19 degree. And each player take turns to play their stones, white or black, on the grid. And it has too many, the combination of actions. You cannot solve the problem, or you cannot make the program win against the human player as Deep Blue win against the human chess player. So, because the search space is too large, we cannot plan everything. We cannot construct any rule to play well in Go game. So I think it's in 20 or 25 years ago, it was kind of this in East Asia, because Go is one of the popular the board game. There's it's kind of the millennium the problem. If you have developed this, like if you can beat the best amateur level, not the professional level of the player, you can earn $1 million or something like that. And now Google AI, the Alphago, actually beat the professional human champion. And it is the follow-up the models of these, the Alphago, AlphaZero, and the others, actually further improving their intelligence afterward. So that is the evolvement of the AI so far we have. And then let's see that, like, take a look at what we have in the more recently and see what this kind of initiate the topic of if AI is threat or not. So AI in manufacturing has been deployed and then actively used. I think it's in a lot of the Amazon model. I forgot the actual number for this the robot that you are looking at, this the orange robot in the bottom of the shelves. That has been deployed a lot in Amazon warehouse. And GM Cruise actually is about to be on our road. Technically there's no problem, but maybe there can be some possible safety issues related to this, the uncertainty of the environment. But if they kind of just let the self-driving car on the road, we can let them move around. Maybe the chances that they get in an accident may be similar to the human chance to get an accident. Only the legislative procedure is left that the car is on the road. And this research is very interesting, that is just using the reinforcement learning and then evaluating the reinforcement learning algorithm in the human dopamine release. And then this research actually relates the AI is the way the learning and the human the learning, and then it actually shows that the high correlation between them, and kind of showing or supporting how AI is running, or how we human design the AI's way to the learning ways of an AI is in the right traction. And in this year, I think it's early in this year, this paper was out that actually spotted the cause and effect. So you can see that the AI can explain the causality of some medical cases, and it actually helps the AI, the doctors to better understand what causes this disease, and then how we can actually better treat the patients. But one thing that the authors mentioned that in this article is it is more likely the help tool, not the way that we can replace the doctor. All right. So now, so far we have talked about this kind of recent the histories of AIs, and then the recent advances in AI. And then now let's think about this, our topic of the AI, if AI is threat to humanity. And there's the AI expert, and then the Dr. Lee, and he has published that this the book that discussing about the threat of an AI. And then in his book, he talked about the AI could replace 40% of jobs. And then what is said, AI will replace repetitive jobs. Those tasks can be automated like robots doing in factories. So the accounting, healthcare, marketing, law, hospitality, and other areas are kind of listed in this book, and will be easily replaced by an AI. Okay. And then there are some other statistics that reports this possible the AI or the replacement in applications and so far. So you can see that this growing number of AIs in AI enterprise applications. And then right here is the automated the jobs, and the food preparation, construction, cleaning, driving, or the agricultural labor and so on. It's highly risky to be automated by an AI. And others actually also report that this 10 jobs AI can replace, and telemarketing, bookkeeping, with the compensation and benefit managers, receptionists, couriers, proofreaders. And I think as a proofreaders is getting better and better. Market research analysis, or computer support supply specialist, and advertising salesperson, retail salespersons. So some easy kind of repetitive job can be easily replaceable by an AI. And what if our future would be like then? Then, as we talked about this, some good advances in AI, what AI can do, how AI can replace, and what kind of things AI can replace so far. Now let's think about then what AI cannot do. So more specifically, what machine learning cannot do. So let's think about the limitations and challenges of machine learning on AI. And here, it's from the Young Fellows in 2015 paper. And you are training a machine learning from data. For example, let's say you prepare a lot of the animal images, and then there are target class labels. So for cat image, and then say the cat, and dog image, dogs, or the hippo images and the hippo, you have all the collected data, image, and the labels. Once you have those data, you can train machine learning model, and then afterward, you can make the machine learning make a prediction, no matter if the images was presented during the training or not. So maybe you can present some new pandas image, like in here, still you can say it's panda, right? That's why machine learning is so popular nowadays. But in this paper, what it actually claimed, you create some random noise like this, and then add this noise only with 0.7%, and then add it to the original image, and that's what you get in the right. And then this image and that image looks same to me with the human eyes, but it is quite different for machine learning. It said in the before it's a panda. Now it says it's gibbon. So your model is messed up. So, and let's take a look at the same problem for the self-driving car cases. So stop sign here and there's, as you can see, that kind of is a little bit tainted. And then, and here as well, it's a little bit of this, the image is gone. It's kind of whitened in the arrow. And after this, the changes of the images or the signs, and then the correctly classifying the machine learning model start to misclassify, and then saying that all three on left are left turn and the right is the step sign. It can be dangerous if you are making your self-driving car model, right? Your recognition of the signs can be wrong. And this is a similar example on the classifying these fruits. And then in these authors make this simple patch on the left looks kind of very colorful. And then if you put that patch right next to the object that you want to classify, now it starts to work in unexpectedly. So above figure actually said is over 90%. It is expected to be a banana. And then now the model after this patch, right next to the image, it's kind of a little sticker. And then you can see that it's very confidently say it's toaster. And it's likely a banana. So your model is not working well. And then we haven't seen a lot of articles that this Tesla or Uber drive the car is crashed. It's pretty scary. And then in the real world, application contains that too many factors or uncertainties to be considered in our machine learning model or AI module. And then fully until it's fully experienced, and then it might not work well on real world. And then how we can make that model to reliable. Maybe a question of the AI scientist. But until then, it's pretty scary to use an AI, especially the application area that is directly related to the human safety. IBM Watson, after winning the Jeopardy game, yes, it was 77,000 to 24,000 and 21,000. And Watson partially beat the other two human players. And now Watson the IBM start thinking about how they use this to the brilliant Watson in what area. And the first area they think about is the medicine. So they aim it hard. We will eventually replace the human doctor with this brilliant AI model. And then after 2 years, what they have done is they realized the promise is overpromised. They were not able to deliver. The way that doctor work is quite different than the way the machine works. And after realizing that, what they say is nothing like the brilliant AI doctor is like a human doctor. So they are more like an AI assistant, not to replace the human doctor. So what we are having at the moment is not perfect enough to replace the human doctors. They had to accept that, right? Now, with having these advances in an AI and machine learning, and knowing the challenges of AIs, and then how we gonna react, how human life will be changed. That's the thing that we may now think about. So according to Dr. Ihsan Rahimi from the Google Brain, anytime you talk about machine learning in medicine, the knee-jerk reaction is to worry that doctors are being replaced. But this is not going to replace doctors. In fact, it's going to increase the flow of patients with real disease who need real treatment. So what is saying, as you can see in this Watson example, the way that the machine learning AI currently working is not complete enough or the perfect enough to replace doctors. It actually helps a lot of these assistive tools, so we can make our doctors do the accurate decisions or this better treatment to the patients. Or even for nurses, one of my colleagues is working on these smart glasses, and then help nurses or the healthcare persons to better access to the patient data to help them better. So something like that, it's more like this automated process is to kind of help them rather than completely replace the people there. And this clinically applicable deep learning paper from Jeffrey and others, and their result was amazing. They were able to diagnose the retinal disease very well. Even sometimes the human cannot recognize, and still they can make that or finding any possible disease in the retina. The problem here is even though the authors actually mentioned, I think I have no. What the authors mentioned, still it requires a lot of the human or the expert help to make the model work. Because we cannot confidently say, even though this shows that given the data that we have trained and experimented, we were able to see this one working well. As the author said, this might not be enough to be placed in the practice. So what the authors suggest is for uses of this one is training purpose. We can use this model to help this like a young the early careers of the doctors and the nurses to easily recognize and help them to learn how to recognize this retinal disease in the image, OCT image. All right. So Kai-Fu Lee is the person who I mentioned in the early in this talk. And this is the book he actually talk about the dangers of the replacing AI, replacing human with an AI. So what he mentions or highlight, even under the catch highlights of the statement of the replacing the humans, what he said is a large number of routine jobs will be eliminated, and large number of pathetic jobs will be created. So maybe that the following one may kind of see, so we are not just simply, or AI might not be there are some possibilities in manufacturing easily, maybe, well, a lot of the automated manufacturing robots are placed in the factory, and a lot of the warehouse robots actually working very safely in the environment. And this article in here actually looking at this different angles and application of AI. In a physiologically or psychologically constrained environment, you can imagine how stressful, how depressed the astronauts if you had to travel long distance, in this case into the Mars. And then we can think about the AI that has or that support the astronaut emotionally. think that's very interesting idea to bring in a very interesting application that AI can help humans. And I don't know how familiar with this, the life of a journalist has been changed so far. So I think it's around 20 years ago, maybe before the internet era. What journalists do is mainly writing a story. And afterwards, it hasn't changed a lot. They need to check how many readers that view their article and how many clicks are they made, and then how many likes they get, and so on and so on and so on and so on. So they had a lot of works, and they have to learn a lot of these tools to help them to measuring their viewerships. It's a heck of work. They don't need to just thinking about and writing a story, not anymore. And AI might help to relieve the journalist overheaded work. That's a very interesting story that I recently read. And another one is the lady, Bernadette Gomez, a Spanish lady, and she was blind over 15 years or something. And so she was not able to see anything. And what we helped them, the AI helped her to regain her sight is, instead of using her eyes, directly communicating to the brain, and she was able to actually see. She can recognize something. So what she said for the first time after gaining the sight is there I can see, there I can recognize something. That is amazing, I think. That is amazing, the help that AI can provide to humans. And yeah, we all suffering under this COVID-19 nowadays. And NIH actually initiated this or promoting a lot of AI researches or tools, so we can actually use for these COVID-19 cases. So there are some researches has been published since in the mid this year, and so using AI to finding other drugs that can be used for the COVID-19, which is the upper one. So drug repurposing research was very interesting. And then this research is like the other, the medical image identification or disease detection. So they are focusing on the chest CT and then how we can automatically detect the COVID-19 using this AI model or machine learning models. And then this research is kind of going further steps. So COVID-19 or middle with the COVID-19 or after COVID-19, how we can relate or predict any severe related illness using AI. And there are many further is proposed and then suggested, and the right way to help human who is suffering from pandemic. So maybe I can stop talking here and share this Super Bowl ad from Google early this year, which is, I think, very touching.
Hey Google, show me photos of me and Loretta. Remember, Loretta hated my mustache. Remember, Loretta loved going to Alaska. and scallops. Show me photos from our anniversary. Remember, she always snorted when she laughed. Play our favorite movie. Remember, I'm the luckiest man in the world. Come on, boy.
Okay. Oops. Oops. Just need to. Let me get out of the. Yeah. That's all for that I have today. Thank you for your attention and presenting here today. I would like to kind of turn the microphone to you, everyone, and then hear your voice. What do you think about the AI and then future of human life?